Okay, here's the situation. You have an LED, you want to make it light up. So you need a battery, and you also need one of these called a current limiting resistor so that the LED doesn't burn out. The question is, how are you going to hook all these things together? Well, one possibility is I could kind of pinch these two wires together, and I could pinch these two wires together, and then maybe kind of just touch the wires together and the LED lights up. Not very practical. So when you're building circuits, you need some way of connecting wires. And sometimes you want those connections to be permanent, and in which case you can solder wires together. Actually use molten metal to connect conductors together. All right, but in the context of physical computing, what you want to do often is you want to prototype. You want to build a circuit quickly and easily so you can test it, but make modifications fairly easily. So what are you going to do? Well, when we're prototyping circuits, we're going to use a device like this. So this is called a breadboard. It's called a breadboard because the very first breadboards were actually breadboards, or boards that were used to cut bread. But this one is not for cutting bread, but it's still called a breadboard. Other people call it a prototyping board. I'm going to show you how it works. Okay. So the first thing I'm going to do is take one of these things apart and show you what is behind here. So if I hold it a little bit closer to the camera, you see there's a whole bunch of ports in the breadboard, and in these ports I can stick wires like this. Okay. Now there's a backer on here, but what I've done is I've taken a breadboard and I've taken it apart. I've taken the backer off so we can see what it's made out of. All right, and so if you take the backer off and you turn it around, what you see is, well, there's still some glue and adhesive and stuff on here, but what you see are these metal bars. They're called bus bars, and the two pieces that fit on the end like this have bus bars that run the long length of the breadboard, and in the middle here you have bus bars that run perpendicular and in the other direction, and they're much shorter, and they're separated by a gap in the middle here. So if we flip over the breadboard, what you see is those long bus bars run along these holes on the side, and those shorter bus bars run along these holes in the middle, and then there's a gap in the middle. I pulled out some of the bus bars so we can look a little bit closer. So here's one of the long bus bars. I pulled that out of one of these side rows or columns, depending on how you hold it. All right. If you take a closer look, what you see is the bus bar is made of metal, so it's a conductor, but the business end, the side that's exposed to the ports on the breadboard, are a bunch of little clips. So if I want to connect two wires together, I stick them in holes on the breadboard, and they get stuck in these clips, and now they're connected. They're connected through the bus bar. There's continuity there. Current can flow through the red wire, through the bus bar, and then through the black wire, so they're connected. So here is one of these bus bars from one of the shorter rows or columns here in the middle. But it looks exactly the same, it's just smaller. So if I were to put two wires and two ports that are connected by this bus bar, then those two wires are connected. Okay, so in short, a breadboard is a device that allows us to make connections between electrical wires that are temporary, but we can do it quickly and create continuity between circuit components and make connections with wires to test and prototype circuits. Okay, so let's actually build a circuit now. Okay, so here is a breadboard that is not taken apart. The backer is still on it. And so just to reiterate again, there's a bus bar that runs along the sides of the breadboard, the long sides, along the entire length. And you'll see here on the front there's some labeling here. This row is labeled with a red line and a plus sign, and this row is labeled with a blue line and a negative sign. And so that does, the reason this is done is these bus bars that run along the side of the breadboard, along the entire length of the breadboard, are typically used for power. So I could plug a battery positive terminal in here and a negative terminal in here, and then all of these ports along the length of the breadboard would be energized. So I can make connections to those ports to get power to components in my circuit on the breadboard. But they don't have to be used that way. I could plug positive in over here and negative over here, and I could still use the breadboard, even though my connections don't conform with the labeling. Doesn't really matter. All right, so let's make this LED circuit. All right, and so I'm going to start by, there's no one right way to do this, but I'm going to plug my resistor into the breadboard in two different columns here in the middle. So the two ends of this resistor are in separate columns, so they're not connected. But if I plug a wire into one of the ports in this column, it's going to be connected to this pin, this wire on the resistor. And if I plug a wire in over here in one of the ports, open ports in this column, it'll be connected to this side of the resistor. Okay. What next? Well, let's plug the battery in, and let's use the power bus bars up here on the top. So I'll plug the red wire in the bus bar labeled plus, and the black wire labeled in the bus bar labeled minus. Okay, so now all these ports are energized with plus 9 volts, and this 0 volts or the negative polarity on the battery. Okay, so I want to plug in my LED. So I need current to flow through the resistor and through the LED in series. And if you look at an LED, one of the pins is always going to be longer. That's the pin that needs to get higher voltage. So it needs to be connected to the higher voltage in my circuit here. So I'm going to plug it in right here. Okay, so I've plugged it in. All right, in such a way that now this wire of the resistor and this wire of the LED are connected because they're in the same column on the breadboard. So now all I got to do is connect power. So I'll connect the positive voltage to this pin and the minus terminal of the battery to this pin, and the LED should light up. So I need more wires for that. No problem. I'll do that. And I'll do this, and bingo, it lights up. So if we trace the current through my circuit here now, here's my battery. Current flows from the positive terminal through the red wire to the bus bar right here that's labeled with the red line. So current flows through the red wire down into this column of the breadboard, through the resistor to this column of the breadboard, through the LED, and then through the black wire back to the negative terminal in the battery. Okay, so just to show you that you don't have to, these wires are sort of superfluous in this situation. It's a pretty simple circuit. I could just as easily have made direct connections to, I could have just plugged the battery cables into the columns of the breadboard. So now current flows through the red wire, through the resistor, through the LED, and then back through the black wire to the battery, and I have a circuit. Okay, so this is a quick introduction to how to use a breadboard. The main points here are that the ports on the breadboard are backed up by a bus bar that allows you to make connections between wires that are plugged into ports in the same column. So if I plug a wire in here and a wire in here, they're connected via the bus bar. But the adjacent column here has a different bus bar. So if I plug a wire in here and a wire in here, they're not connected. And then you got these special bus bars, which instead of running up and down, run left and right, and they're typically called the power bus bars, because they're typically used for supplying power to the breadboard, but they don't have to be. Okay. One more thing. So this central channel here, what we'll find is it's very useful for when we're using integrated circuits that come in what's called a dual inline package, or DIP package. You can plug the IC in across this channel here, and then the pins on one side of the IC are isolated from pins on the other side of the IC, so then you can make connections between wires and other circuits components and the pins in the integrated circuit. Okay.